Okay, so here's number 1. 5.1, exploring data, statistical reasoning. Question number 1 on page 211. Your textbook, Pearson, Foundations of Math 11. Love it. Okay. So the question says, construct a graph to illustrate the average daily temperatures in Langley, BC and Windsor, Ontario. So we are going to construct a graph. Now, the types of graphs that we have, if we go back up to the types of graphs that we have, and we haven't talked about this quite yet because we're going to talk more about it in section 2, but frequency distribution, a histogram, all that sort of stuff. What kind of graph do you think we should make here?
Frequency polygon.
Okay, so what is a frequency polygon? Let's talk about that. Who described? Did anyone get there? Frequency polygon? Can you? What's your definition for that?
Frequency polygon is basically person.
Yep. So a frequency polygon is we're going to place the data like a scatter plot. So like we're going to have an x-axis of a quantity, a y-axis of a quantity. We're going to plot the point somewhere, and then between the points we're going to draw straight lines to connect them. So that's a frequency polygon. Data plotted on a graph with straight lines connecting each point. Okay? So if we're wondering about that definition, if you haven't got there yet, that's the definition of a frequency polygon, and that's what we'll do for this one. So it's kind of like a line graph. Some people call it a line graph. A line plot is different. We talked about that, but a line graph. Okay, so what we need to do here to graph is we need to decide what the range of values is. Because if you see, we're going to have months here, and we're going to have daily average temperatures on the y-axis. So the temperatures are going to be the measured values, and then the months of the year are going to be on the x-axis, okay? Because they're not changing, all right? Thanks. So the months don't change. We live in a month, and then we measure the temperature, average temperature, right? So whatever we measure is what goes on the vertical axis, okay? So we also see we have 2 different cities. So on the same graph, we're going to graph both plots of data on the same graph. So what I would encourage you to do, I'm going to cheat a little bit by making some very nice straight lines here. But make a graph here, sort of something like this. Okay. And I might make mine just a tiny bit higher than that if I can. And what we're going to do, we don't have, if you have graph paper, you can go ahead and use graph paper. Not 1,000% necessary here right now. But what we're going to need to do is we're going to need to find out sort of what our lowest temperature will be and what our highest temperature needs to be. Okay, so we do need to talk about what is the range of values for each of these. Okay, so what's my lowest temperature that I see here in the upper chart? Anyone see it? 2.2. Is that the lowest? Okay. So what's the highest temperature? 17.0. Okay, so here we're going to have 17.0 minus 2.2. So that's going to be what? Is it 14.8?
Yeah.
Okay, so 14.8 is our range, and we can go kind of from 0 here and up, right? But if I want to put Windsor's daily temperatures, I can see I have some negatives in the winter. See, it's colder there. So what's the range for Windsor? The highest is 22.7, and then a negative 4.5. Okay, so we're going to do largest minus the smallest. So you're going to do minus a negative. So that's going to end up to be 22.7 plus 4.5. What's that? 27.2? Okay. Okay, so these are the ranges, right? Now, obviously, I'm going to have to allow for the largest range. We want to put them both on there. If you have, and I'll talk about this a little bit more later, if you have a certain number of like squares or divisions, what you want to do is you want to take your largest, your range, and divide it by the number of squares you have, okay? And then you want to round up just a little bit so that you can fit everything on your data. So again, take your range, if you have graph paper, the range divided by the number of squares, that you have. So let's say I had like, whatever that is, 7 or 8 or 9. So that I would take the range, and my largest range is 27.2 divided by 9. Let's see if that's what I have there. I don't know, but something like that. Then what's that? That's going to be 22.9. 22.9 divided by 9 is going to be 2.5. So what you might do then is you might round this up to 3, something that's fairly reasonable. Then each square could be 3 degrees, and you'll be able to fit all of your range and all of your data in there. Okay. Now where you start, it depends on where you start, right? So you have to make sure you start low enough, and then you'll be able to end high enough. Okay. So I do not have a given number of squares here. I'm just going to assume that we're not going to do this calculation so much here for this one. But I need to start somewhere below negative 4.5. So I'm going to start negative 5, let's say here. Okay. And I'm going to take as many squares as I need. Let's say it's kind of rather unlimited. I need to go up to a maximum temperature we said was 22.7. So I need to go up to at least 23 or 25. Do you know what? 25, these are both multiples of 5. So I bet you that I could make this work, okay? So if you went up by 5 each time, let me see here. I'm going to try and, so I'm going to go 0, and then 5, and then 10, and then 15, and then 20. So I'm going to try and make this nice and even. Each square has to be the exact same amount, and that's as close as I'm going to get there. You have lines on your paper, or you have a graph paper. You can make sure these are good. Okay. So setting the y-axis, you should label this too. So temperature. This is temperature. You can actually say average temperature, and you have to put the units there too. So put degrees Celsius. And on the bottom, yes, we're going to do the months. So we're going to go January, February, March, April, May, June, July, August, September, October, November, December. Did you know the name Jason is in there? Jason D. Anyone know a Jason D?
Well, my brother is Jason, but he's Jason Micah Coleman, so there's no D.
Okay, so there's no D, but yeah. You guys know that in the months listed? Jason's in there? Okay. Anyways, very cool. Okay, so another thing we have to do here is if we've got 2 cities, 2 sets of data, we need to distinguish one city to the next. So let's make Langley a red dot, okay? And then we'll make Windsor a blue dot, okay? So the data sets. So let's go with Langley first. So in January, I need to put, and again, as accurately as I can, precisely as I can, I need to find positive 2.2 for January here. So, whoops, come on, red. So 2.2 is going to be right there, make a dot. And then move on to February is 4.4, put a dot, and so on, 6.3, 8.6. So go ahead, you guys are doing this right now. Hey, you're not just watching me, you're doing this on your paper, this is your homework. January, February, March, April. So go ahead and carefully plot this on there. So 8.6, you're going to do your best to line that up, 8.6 and so on. May is 11.8. June, 14.2. And so on. So just go ahead and finish putting the dots on there for both cities, okay? Okay, this is what Langley kind of should look like. If you don't have 2 different colors, use a dot and an X maybe, okay? So, all right, I'm gonna get rid of this here right now. Okay, and then we'll go ahead and put, we'll have to connect these with straight lines, and then we'll do Windsor on here as well. Okay, so go ahead and take a moment to finish that up. Okay, so as you plot that data there, month, okay, make sure you label. So average daily temperature or average, average daily temp for Langley. Let's see, was it Langley and Windsor? So average daily temperature, and somewhere you need to put like a little bit of a legend or whatever, like, so the red dot is Langley and the blue dot is Windsor. All right, so when I'm looking at your graphs, guys, I need to see things are evenly spaced out. I need to see you have quantities and units. If applicable, months don't have units. You need to have a title as well, please. Okay, so a lot of students don't do the title. I need to see a title, at least a general title, okay? And then if you have more than one city or more than one quantity on the same graph, please make sure you differentiate them, okay? All right. So construct a graph to illustrate for both of these cities. All right, so we've done that. Now, a graph is actually really handy because we can see visually pretty quickly what the sort of general weather is throughout the year for these two cities, at least in this particular year that was measured. So we can tell that Windsor gets colder in the winter, on average, than Langley, BC. And we can also tell that on average, Windsor gets a little hotter than Langley, BC. So the temperature is a little more even. It does not vary as much. The temperatures are not dispersed as much in Langley as they are in Windsor, right? Question or comment?
Saskatchewan has the highest range.
Yes, that's right. So we live in Saskatchewan, and our graph, Saskatchewan graph, would probably be like way down here, probably going way up here, and then way down here again, right? That's probably where we would be, something like that. Yeah, it gets very cold, very hot. Being in the middle of the continent, we don't have the luxury of the stabilization of the oceans, right? So it gets pretty cold because we're far away from the oceans, releasing their temperature in the winter, and we're pretty hot because we don't have the rains and the cloud cover and all that sort of stuff. Yeah, generally. Okay, hey guys. Okay, so B says determine the range, mean, and median for the average daily temperatures in the two cities. So the range, okay, we already talked about the range. Okay, so there's the bell for a shortened class here. So you guys need to finish this one today, and your assignment is number 1 and number 2. So for 5.1.